Hello, Ollie, and welcome. It is a long time. It's been a long time since we've done a video. Today is going to be Chapter 5, Lesson 1 in preparation to move along into Chapter 5. But don't forget, we do have the Chapter 4 test coming up next week. Section 1 of Chapter 5 is entitled Exponents, which I believe you've heard of, so this should be a good one. I will use exponents to simplify, but of course we're leaning more toward our algebra skills to simplify algebraic expressions. So where we might have multiplied integers or even whole numbers, now we're going to be able to multiply or simplify expressions with both numbers and variables. Getting towards using scientific notation and laws of exponents, that's where we will be heading in the next couple weeks and in the next couple years. All right, so what are exponents? Well, quite frankly, quite simply, an exponent is a number that tells how many times the base is used as a factor. Sorry if that's not the best way of putting it. Really, I'd like you to focus on the word power, because a power means repeated multiplication. In this case, 5 to the third power, 5 is the base, it is the repeated factor. 3 is the exponent, it tells you how many times that factor is repeated. So in this case, 5 to the third power, 5 times 5 times 5, 5 times 5 is 25, 25 times another 5 is 125. You should have already seen most of that in previous years. Let's go into writing as a product of the same factor in, whoa, there's Mr. Cowan's pet peeve. We are most certainly not solving. You can say compute, you can say simplify. Most of us will say evaluate. But please don't say solve. So first, we're going to write it as the product of the same factor, 4 to the third power. 4 is the base. The 3 tells you exactly how many times that 4 will be repeated. 4 times 4 is 16. 16 times another 4 is 64. Part B, 7 to the second power. Remember, please, the most common mistake is 7 times 2. That does not mean 7 times 2. It means 7 multiplied by itself. 2 to the sixth power. 2 multiplied repeatedly 6 times. So let's just take it piece by piece. 2 times 2 is 4. 4 times another 2 is 8. 8 times another 2 is 16. 16 times another 2 is 32. And 32 times another 2 is 64, which for those of you that understand computing a little bit, 64 is one of those magic computing numbers used in bits because, of course, in computers, they only understand zeros and ones. And so we find ourselves multiplying by powers of 2 when you go from bytes to megabytes to gigabytes, etc., etc. I skipped kilobytes, didn't I? 10 to the 8th power, 10 multiplied by itself 8 times. Which means we have a 1 followed by 8 zeros. Yellow sticks out a little better. Did I do too many? Or did I put my comma in the wrong place? 10 to the 8th power should be 100 million written in standard form. All right. Evaluate each expression. Why don't you go ahead and hit pause, get some scratch paper, come on back when you're ready. In this case, 3 to the third power, 3 multiplied repeatedly by itself. 3 times 3 is 9 times another 3 is 27. 2 to the fourth power. 2 times 2 is 4 times 2 is 8 times 2 is 16. And guess what? 4 to the second power, also 16. Now, let's talk about this ever important 0 power. And I'll tell you right now, most people think a number to the 0 power is 0, but that is not true. Now think about it, just build it up. 2 to the first power, that's a single 2. 2 to the second power, 2 times 2 is 4, times another 2 is 8. 2 to the fourth power is 16. And we could go on and on and on. But instead, I would encourage you, take it backwards. And what do you notice is happening? Well, it would appear that every time we go the other direction, we are dividing it by 2. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. Okay, so what is 2 divided by 2? Any number to the 0 power is always equal to 1. And by the way, that would work if we would have built a row of 3s or 4s or 5s. 25 divided by 5, 125 divided by 5 is 25. And 25 divided by 5 is 5. All right. So then what is 5 to the 0 power? Divide by 5, divide by 5, divide by 5 again, and there it is. So please do not fall for that false notion that any number to the 0 power is 0. It is in fact 1 whole. Although I would love you if you could find the exception to that rule. Is there any other number raised to the 0 power that is not equal to 1? Hey, we're in mathematics class, right? So there are rules and there are exceptions to rules. Sometimes we can explore those and have a little fun mathematically. Now, what if we go the other direction and simply write it in exponential form? Once again, don't forget, we are multiplying a base to an exponent because 4 is the repeated factor, 4 is the base. And because we see this multiplied by itself repeatedly 3 times, we're going to write this as 4 to the 3rd power. For the next part, we have 9 multiplied repeatedly 1, 2, 3, 4, 5, 6, 7 times. And for the next one, we have 7 multiplied repeatedly 9 times. Little exploration. Think about if that is the same amount. Is 9 to the 7th the same amount as 7 to the 9th? Think about it if you wish. And for those of you multiplying out, you will find very quickly it is not. What if there are variables? Okay, so how do we represent numbers? If we know the number, we can write the number. If we don't know a number, we assign it a variable. Take a look at this example where we see n multiplied by itself repeatedly, and I'm seeing 4 of those. If you see multiple variables, getting you ready for algebra, you will always want to write those variables alphabetically if at all possible. And in this case, we multiply a repeatedly 3 times and b multiplied by itself 2 times. Now, what if we have 2 different constant, or should I say coefficients in this case? Well, please recall that the commutative property says we can change the order and still have the same product. So now it's a little easier to see. How do you simplify 3 times 2? 6, of course. And how do you simplify n multiplied repeatedly? Well, let's go ahead and write it in power form. We'll do the same thing here, or perhaps you can do it mentally. 4 times 3 is 12. We have c multiplied by repeatedly number 1 and number 2, c to the 2nd power, and then we have d to the 2nd power. Do not, well, never mind. I was going to give you a little preview of coming days. Can I ask you to please note as we get into our assignment that you will have a textbook assignment and you will have a worksheet. I will put the worksheet on Google Classroom. Also note, for problems 2 through 36, I would expect you only to write the directions, the problem, yes, you need to write the original problem, and the answer, but there will be no work to show. What can I say except you're welcome? Ooh, bad movie joke, Mr. Cowan, bad movie joke. So after you complete page 123, that would be numbers 2 through 36 evens and number 37 and number 38. Head on over to the worksheet. I took care of both of those within less than 15 minutes, so I'm hoping it only takes you about 30 minutes. The worksheet looks like that if you want to preview. That's all I got, folks. Let me know if I can help, and I will see you soon. Have a great day, and let's grow.